play the Predators game? I will be Cephalopods. So I will pick this one.
Anomalocaris.
Yes, and this guy.
Okay, I start so. So our story starts here in Ediacaran Period, with these unusual multicellular organisms.
The boundaries of the Ediacaran period starts with the end of a global glaciation and goes on until one complex trace fossil. This earliest reasonable fossil record of animals, nicknamed garden, was composed by soft-bodied animals, probably autophototrophic and without any predators. So why we're talking about it? The mysteries around this period, mainly the transition from late Precambrian to Cambrian, lead us to think when the predators appear, and why did the evidence of Ediacaran life abruptly end at the beginning of the Cambrian period?
When we look at the impressions of the soft-bodied animals, you can imagine how difficult it was to preserve them. A first model goes that they didn't suddenly disappear, but you just can't find them, because the Cambrian became much more active, preventing their preservation. A mass extinction model used to be the preferred one, but a biome-replaced model where the Ediacaran organisms were progressively outcompeted by new clades from Cambrian is gaining much more followers in the scientific community. The animation obviously is an overkill, but new species like Anomalocaris appear in the late Precambrian, some of the earliest known calcified organisms. What happened with the Ediacaran Period and how the Cambrian Explosion began is still a mystery. We can't ignore the chemical change in the ocean, but could the rise of the predators be a definite factor for these questions?
Yes. 1, 2, 3, 4, 5, 6. The Cambrian period marks the beginning of a mass diversification of body plan and an evolutionary arms race that will continue to this day. 505 million years ago, the Anomalocaris was swimming in the Iapetus Ocean. This was the largest fossil found at the Burgess Shale in Canada and could reach up to 2 meters in length. A microturbidite will occur off the Cathedral Escarpment any minute now, which will create the Stephen Formation and preserve this creature until it is excavated by Charles Doolittle Walcott. The Anomalocaris was the undisputed champion of the Cambrian Ocean. With its hydrodynamic body, spiny frontal appendages, and advanced eyesight, it would inspire fear into any creature at that time.
The Anomalocaris is believed to be the first apex predator on planet Earth. But what did it eat? An idea proposed by Derek Briggs and Harry Whitcomb suggests that it ate trilobites. It ate trilobites by flexing the trilobite, which takes advantage of the weak tensile strength of cuticle, which is made of, so it could break it and eat away to its heart's content. However, from all the mouth parts that have been found in the fossil record, none of them show any kind of damage, which you'd expect to see if it was eating a calcareous creature. This has led to a scientist called James Hagrenor to suggest that Anomalocaris actually ate soft-bodied creatures like worms.
Okay, I think it's my turn now. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Hold on.
What?
Yeah, the Anomalocaris was actually found at the beginning of the Ordovician, so I'm there now.
Alright. Anyways, the Cephalopods started appearing in the Cambrian, but had their massive peak in the Ordovician.
Extant cephalopods, which we are familiar with, include squids and octopuses. Reports of giant squids found in Japanese waters and poisonous cuttlefish and octopuses emphasize their carnivorous and predatory lifestyle in our oceans today. This is a 5-metre piece of string and represents the size of the early nautiloids, which had their peak in the Ordovician period.
Nautiloids are thought to have moved through the water column vertically in search of prey, which they shed apart with a chitinous beak. Prey items included brachiopods, such as these ones here, with bite marks from the Ordovician on them. Few bite marks also have been found on trilobites.
Another group of cephalopods, distinct from the nautiloids by more complex sutures, are the ammonites, which appear in the fossil record during the Devonian some 400 million years ago and became extinct in the Cretaceous. Ammonites, however, are not thought to have been an apex predator of the ancient oceans, but rather filled the niche of modern filter feeders as well as crustaceans such as crabs and lobsters. Colloids describe the last and probably most obscure group of cephalopods. They greatly differ in their appearance to that of nautiloids and ammonites. The main notifiable change is the internalization of their shell.
Due to the internalization of their shell and the increase in gelatinous body parts, these chambered belemnite shells are the only remnants we have from the belemnite group today. Extant survivors of the belemnite group include shallow water cuttlefish and deep water spirula.
Modern day predators of the oceans might be dominated by fish, but reports of squids attacking sharks show that they still play an important role at the very top of the food chain.
So, after Anomalocaris and Cephalopods, what became the next apex predator? So the next predators started to evolve in the Cambrian about 500 million years ago, but didn't actually become an apex predator up until the Middle Silurian. After Anomalocaris and Cephalopods, what became the next apex predator? This was the aquatic vertebrates, in particular the evolution of fish. But what exactly caused these fish to become the most dominant predator in these ancient oceans? Most scientists would agree that this was down to the evolution of jaws. The first aquatic vertebrates occurred over 500 million years ago and were known as ostracoderms. These prehistoric fish ranged from 7 to 25 centimeters in size and consisted of cartilage skeletons and bony protective armor on their exterior. These fish were jawless. They most likely were bottom feeders, clumsily swimming along the sediment-water interface in search of food. Around 430 million years ago came the appearance of a new species of aquatic vertebrate known as placoderms. These fish were superficially similar to the ostracoderms with hard armored exteriors, but had one large advantage: jaws. These jaws allowed the fish to feed on small aquatic organisms and actively hunt. But how did these fish actively evolve such a simple yet effective appendage such as a jaw? Well, the main hypothesis is that these jaws evolved from two parts of skeletal cartilage, the mandibular arch and the hyoid arch. Both arches grew and elongated over time, allowing the production of a hinged mouth. This, however, is believed to be at first being developed to help oxygen intake and not for eating. These early gnathostomes eventually allowed the evolution of teeth. This allowed them to exploit new food resources that otherwise were not available to their jawless relatives. So how effective was the evolution of the jaw? This is Dunkleosteus, a fierce predator from the late Devonian. The largest of these prehistoric fish grew up to 10 meters in length and weighed over 3 tons. Its large armored head and powerful jaws allowed this creature to be one of the most effective predators in the Devonian seas.